All right, so today we're going to talk about drawing Lewis structures for molecules. And we're going to start with this molecule, SCl2, sulfur dichloride. And we're going to just follow these steps. So the first step says determine the total number of valence electrons in the molecule. So if we just go to the periodic table, we've got sulfur here that's in group 16, so it's got 6 valence electrons. So we got 6 of those. Okay, and then we're going to say each chlorine has 7, right? But there's 2 of them. All right, so that's going to give us 14. So 14 plus 6 is 20 valence electrons total, right? Okay, and then step 2 says draw the skeleton structure with the least electronegative atom in the middle, or the atom that needs to make the most bonds. So if you don't have a table of electronegativities handy, you can just kind of do it based on the one that needs to make the most bonds usually goes in the middle. So for example, what we mean by that is chlorine has 7 valence electrons to start with, so it tends to only make one bond to become like argon. And so sulfur, though, needs to make 2 bonds to become like argon, so sulfur would be the one that makes the most sense to go in the middle. So we draw what's called our skeleton structure with S in the middle, and then in this case a Cl on either side, just like that. Okay, so that is step 2. And then it says connect the atoms to the central atom with single bonds. And so a single bond in a Lewis structure for a molecule is just a line that represents 2 electrons. So now we've used 4 more electrons, so now we're down to 16 that we have remaining, right? Because each of these bonds represents 2 electrons, 2 valence electrons. Okay? Then the next step says to complete the octets of the more electronegative atoms first using the remaining electrons. So that just means with the remaining 16, we're going to go around the outside atoms first. And you can see this chlorine only has 2 right now, so it needs to end up with 8, right? So I'm going to, this time I'm going to put these guys in groups of 2 all around chlorine, right? So it's going to get, now it's got 2, 4, 6, 8, right? And then I'm going to go over to this chlorine, and remember, we're paying attention to the outside atoms first. And so now it gets 6 as well. So if we just kind of keep track here, we've added an additional 12 electrons. So 2, 4, 6, 8, 10, 12. So of my remaining 16, I just used another 12. So now I'm down to 4 left. So I only have 4 electrons left, and those are going to go on the central atom, the one that needs it, right? So those guys are going to go there, and that gives all 3 of these atoms 8 valence electrons and makes them all happy. Okay, so if we take a look then at the next step, we have HCN, okay, and then it does say we have another little step here. It says if you still have electrons remaining, which we didn't, right? We used up all 20 of our original valence electrons in this molecule. So this molecule is fine. It's done. Nothing else needs to be done. Okay. So we put the remaining electrons on the central atom. Sometimes though you run out. Okay. So let's take a look at this guy. So we have hydrogen. Hydrogen has 1 valence electron. Carbon, if you go to the periodic table, has 4, right? And nitrogen, if we go to the periodic table, is in group 15, so it has 5. And if we add these 3 guys up, 1 plus 4 plus 5, of course, is 10. So we have 10 total valence electrons to work with, right? In terms of the one that needs to make the most bonds, if we go to the periodic table, again, that's going to be carbon, right? Because carbon only has 4 electrons to start with. Hydrogen only has 1, but it really only needs 2, right? Because it only has 1 energy level, so it's trying to be like helium, which only has 2. So hydrogen only ever needs to make 1 bond, right? So hydrogen will never go in the middle of any molecule because it only needs to make 1 bond, which means it only, it can't connect to more than 1 atom, right? So between carbon and nitrogen, they both need to make more than 1 bond, but carbon needs to make the most. So we're going to put it as the central atom. And then we're going to put nitrogen on one side and hydrogen on the other side, and that way carbon can make lots of bonds, right? Okay, so we're going to start just like our previous one. We're going to start with putting the single bonds in, and that actually takes care of 4 of our 10 electrons, right? So now we're down to 6 to work with, right? Okay, and then it says to, on step 4, complete the octets of the more electronegative atoms first. So that's going to be nitrogen is more electronegative than carbon. And then so I'm going to go ahead and put the remaining 6 electrons on this nitrogen, right? And this hydrogen over here doesn't need any more, so it doesn't get any more. The problem though is I've used all of my remaining electrons. I don't have any left, right? So we did step 4. We completed the octets of the more electronegative nitrogen atom. The problem is we don't have electrons remaining. So we're out of electrons, and carbon right now only has 4 valence electrons, so it needs 4 more, right? So the answer when we run into this problem is to do more sharing. So the question we're trying to take care of here is carbon, how do we get carbon more electrons without taking away from nitrogen, right? Of course, we can't take away from hydrogen because it only has 2, but we could potentially do a little bit more sharing here. So the way this is going to work is instead of these 6 electrons all belonging exclusively to nitrogen, what if we got rid of these dots and instead created a double bond, right? And that would at least get us up to 2, 4, 6 on carbon while still maintaining 8 on nitrogen, right? So that doesn't quite get it done, so we're going to have to go even further, right? So let's do even more sharing, and this is going to end up being a triple bond. So again, we're taking those unshared or formerly unshared electrons that I had originally drawn on this nitrogen and turning them into electrons that are now shared between the nitrogen and the carbon. Okay, and so this hydrogen has 2 valence electrons, which is all it needs because it just wants to be like helium. This carbon has 2, 4, 6, 8, and this nitrogen has 2, 4, 6, 8. And so this is what we would call a triple bond. Now, once you learn how to double and triple bond, a lot of times students will want to apply that to everything that they do. Only triple and double bond when you need to. In other words, when we ran out of electrons and we still needed some more on carbon, that's why we did more sharing. Up here, we had lots of electrons. We had 20 electrons to work with, and so it ended up being more than, or it ended up being enough for everything to have 8, even though we were only doing single bonds.